At noon, boats P and Q have position vectors r and velocity vectors v as follows. Rp, which is the initial position of the boat P, is I plus 4j kilometers. Its velocity is 6i minus 2j kilometers per hour, which means each hour it's going 6 kilometers east and 2 kilometers south. For Q, the initial fixed position is negative 8i plus 13j kilometers, and the velocity 7i minus 3j kilometers per hour. Prove that if P and Q continue with these velocities, they will collide and find the time of the collision and the position vector of its location. So, first of all, Rp of T is going to be, so this is the fixed point, so that's going to be 1, 4, and I always do it as column vectors, so the I goes in the top, j in the bottom, and that's going to be plus t times the velocity vector, which is the direction, and so that is 6, negative 2. Rq of t would be negative 8, 13 plus t, 7, negative 3. Now, for the things to collide, that means that they have to be in the same position at the same time. And that means that both the I and j directions will need to be the same. So we can say that 1 plus 6t, that's the I for P, would be equal to negative 8 plus 7t. And that gives me t is equal to 9 if we solve that. Then for the j's, we need to check that that works. 4 take away 2t would be equal to 13 take away 3t. And that also gives me t is equal to 9. So they are at the same position at the same time. To find that position, we can substitute back into either. So I'm going to use 1, 4 plus 9, 6, negative 2, which is going to be 1, 4 plus 54, negative 18, and that gives me 55, negative 14. So, how far from the scene of the collision is the nearest coastal heliport? The position vector of that being at negative 10i plus 12j, the helicopter base from which help will arrive. So, the heliport would be here at negative 10, 12, and the collision is over here at 55, negative 14. And we'll presume that we fly directly there. How far would we want to go? So we can see that negative 10 to 55 is 65 that way, and 12 down to negative 14 is 26 that way. This is a right angled triangle, so the distance is found using Pythagoras' theorem. So d would be the square root of 65 squared plus 26 squared, which is 70.007, and so that is approximately 70 kilometers. Now, we didn't have to draw the diagram. We could have found the relative position, that's the position of this one from this one, by doing 55, negative 14, that's the scene of the collision, take away negative 10, 12. And that would have given us 65, negative 26. And then we find the magnitude of that. We're going to discuss magnitude shortly. And it is just a distance. So it's the square root of 65 squared plus negative 26 squared. And that gives us the same result.